Okay, so for this question, we want to sketch the graph of sec x plus 3 plus 1 over this domain with no calculator. So one way we can do it is to start by looking at the graph of cosine x and building up towards the sec graph, because remember sec x is the reciprocal of cosine x. So the graph of cosine x, if we just look at over the domain 0 to pi, it's going to start from its maximum and end at its minimum. The midpoint is going to be at pi on 2. It's a half period. Okay, the full period would be 2 pi. Now, the next step would probably be to apply the horizontal translation. So if we look at now x plus pi over 3, what's that going to do to the graph? It's going to shift everything pi on 3 to the left. So for this graph, this x-intercept, which was at pi on 2, once we subtract pi on 3, that's going to be down here at pi on 6. The minimum, which was at -1, well, it's still going to be at -1, but once we shift it pi on 3 to the left, that's going to be 2 pi on 3, -1. For our y-intercept here, that's going to come from where this graph was at x equals pi on 3. So cosine of pi on 3 is a half. So once we shifted that point pi on 3 to the left, that's going to give us our x-intercept at 0, comma, a half. Okay, so we've got that. The other endpoint is going to be when this graph was at 4 pi on 3. Okay, because you're going back pi on 3 to the left, and cosine of 4 pi on 3 is negative a half. So that endpoint is going to be pi, comma, negative a half. Okay, so that took a while, but we've got now our cosine x plus pi on 3 graph. And the next step we're going to do is to take the reciprocal to get the graph of sec x plus pi on 3. So when we take a reciprocal, anytime we had a 0, an x-intercept, we're going to get an asymptote because we can't divide by 0. So here we get an asymptote at x equals pi on 6. For the endpoint, which was y is equal to a half, when we take the reciprocal, are we going to get y is equal to 2? So that's 0, comma 2. Similar for the other endpoint, which was negative a half, that's going to give us the point pi, comma, -2. And this local minimum is now going to become a local maximum. The reciprocal of -1 is still -1. So that gives us the local maximum 2 pi on 3, -1. Okay, so we can fill in the shape of our graph now. This is a local maximum, and then the graph's going to come back down and approach the asymptote. On the left side here, um, that's our y-intercept, and then we're going to approach the asymptote as the cosine function approaches 0. The sec graph would approach infinity. So after those steps, we've got the graph of sec x plus pi on 3, which is pretty much what we want here, but we still need to do one more step, which is to shift this whole thing up by 1. Okay, and maybe even try to draw a nicer graph with a ruler, etc. Shift all these points 1 unit up. I won't sketch it with my pen here, but I'll show the solutions here on 10-minute quiz. So we can see what the graph should look like. And there it is there. We can see that point 2 pi and 3, -1. Once we shift it 1 unit up, this has become our x-intercept, 2 pi and 3, comma 0. Asymptote here stays the same, and the left endpoint and right endpoint there. So that's one way of sketching a sec graph. We're starting with a cosine graph and building it up step by step, taking the reciprocal. The other way to do it, which is what I've got here in the written solutions, is to just deal with the sec function directly and um, use substitution to get an endpoint. So sub in x equals 0 into the function to calculate the y value, sub in x equals pi. To get the x-intercept, solve for when y is 0 to solve for x, and the asymptote, solve for when the cosine function is equal to 0. So I've written that method out here. I'm starting with the asymptote, solving for x, using substitution to find the left endpoint and the right endpoint, and then solving a little equation to find the x-intercept. So that's another way of sketching the sec graph. It's a fair bit of work, but definitely important concept for specialist maths.